In this video, we'll walk through building an interactive AI chat app like ChatGPT. This app will also support sending messages and receiving responses via WebSockets, image upload, and sentiment analysis. This is a harder take-home task than most, especially given the time constraints of spending no more than 6 to 8 hours on the project. This project was actually given to me by an AI startup, and essentially they were trying to see if I could contribute from day one. The technology used is Python's Fast API for the backend, React with TypeScript on the front end, and this is exactly the tech stack they were using. And they also wanted to see, was I capable of interacting with LLM providers, which is exactly what they were doing via WebSockets. And on a side note, if you're struggling with technical interviews, I used to be there, and I highly recommend you check out TechPrep.app. It helped me land offers from top tech companies like Amazon, Stripe, and Palantir, and I'm sure it will do the same for you. So let's dive in. So firstly, let's walk through the requirements. Our job is to build a chat application UI with a WebSockets integration to interact with GPT. The application will allow users to chat with an AI assistant while visualizing response characteristics. It'll feature real-time communication with the backend and an intuitive user experience. So we are being provided with a React template repo for the front end and a Fast API template repo for implementing the backend. So the tasks we have to implement is first a solution overview. So we have to provide commentary on our solution and add it in a README. Obviously for this, we won't do it, but if it was a real take home, you would have to describe your solution here. So number 2, backend WebSocket implementation. We have to create a simple WebSocket endpoint using Fast API that accepts user inputs. For each user input, we have to generate a response using GPT, and then we have to send that generated response back to the client over a WebSocket connection. And we also have to implement proper error handling and connection management. Next, we have to have a chat interface implementation. So we need to create a responsive chat UI with a clean and modern design. We have to implement a main chat panel where the user and AI messages are displayed. And we have to add input controls for users to submit messages. And we have to connect to the WebSocket endpoint to send user inputs and receive AI responses. And then we have to display the AI responses in real time as they arrive from the backend. And then for the response visualization, we have to display AI responses with appropriate styling to distinguish it from user messages. We have to implement a simple visualization component to show basic metrics about the response. So response time, the length of the response, the sentiment, and we have to allow users to provide feedback on AI responses. So thumbs up or thumbs down. And for a bonus task, we have to implement response streaming from OpenAI API to the front end through WebSockets. We can also add a typing effect visualization for streaming responses. We could implement image upload functionality, allowing users to send images to the chat. And we could also enable OpenAI's vision capabilities to analyze and respond to those uploaded images. And finally, to add a responsive design for mobile and tablet devices. So for technical considerations, they recommended the front end should be built using modern React practices, so using hooks, context, etc. The backend should use Fast API for implementing the WebSocket endpoint. We should use proper error handling and loading states in both the front end and backend. And then we should implement WebSocket connection management, so connection, reconnection, and error handling. We should optimize performance and user experience, and we should write clean, well-documented code following best practices. These best practices including component composition, so building reusable UI components with clear responsibilities, state management, so using appropriate state management techniques for different types of data, and responsive design, so ensuring the application works well on various screen sizes. And so for the evaluation criteria, we'll be judged on our ability to clearly articulate our solution in the README. We won't be doing that here. Our ability to write clean, optimized code that solves each of the tasks, our ability to create an intuitive and responsive user interface, a front-end architecture, decisions and code organization, implementation of the WebSocket communication between front-end and backend, and understanding of asynchronous programming concepts. So this is what I was given from the AI startup. So let's dive into the starter code now. So in the backend, in our source folder, we have our main Fast API set up here. And as you can see, we have a router and we're importing that from V1 router. And so if we go into our routes here and we go into V1, we can see our endpoints. And here we just have a simple WebSocket endpoint that is simply passing. We also have an end file here. And very importantly, you should add your OpenAI API key here. It's super easy to get it. Just look up OpenAI API key and you'll be able to sign up for one for free. We also have a Docker file as this project has been containerized. So here we're going to be using the Python 3.9 image. We then install the system dependencies. We then set the working directory, set the Python path, install our dependencies, and then finally expose port 8081 and then run our start command. And then in our front end here, again, this is a Next.js application. So in our source, we'll have our app, and inside our app, we will have a page, which will simply show front end. And then we also have a root chat, which again is just another page that simply displays chat. Again, we have another Docker file here using the node image, setting our work directory to be app, copying in our package.json, running npm install, copying all the files over, then running npm run build, exposing port 3000, and then running npm run dev. And then at the top level, we have our Docker compose file. This is really good for orchestrating multiple containers. So again, we have our backend here pointing to our backend Docker file. We're mapping port 8081 from our container to our local computer and also hooking up this app network here, which our front end also uses. And we've also added a makefile here to simplify the commands. This is a nice touch as well. So we've got dev here. So this will be used to run our development server. And we also have stop, which will stop all of our containers. So now that we've had a look at the codebase, let's run make dev to start up our development servers. So if I run make dev, this should get both containers up. Again, our backend will be exposed on port 8081 and the front end exposed on port 3000. So they're up and running perfectly. We can see the front end. And then if we go to chat, we should see chat. Perfect. Okay, so the front end is set up. Let's check the back end. So we can check the back end by just running a simple curl request and hitting the health endpoint. And as you can see, it's returning okay here. And that health point is in our source folder. It's in our roots. And you can see that health endpoint there. And so that means our front end and back end have been set up successfully. So before we implement the WebSocket route to make OpenAI requests, let's first ensure we have our tools installed. So let's run pip install pip tools. Cool, have that. Let's cd into our backend now. Now we're going to compile our prod requirements and then output it to the requirements.txt file. And then let's do the exact same for dev, and we are going to output it to the requirements.dev.txt file. Perfect. I'm going to move up one level to the top layer and then run make restart to start our server. Again, make sure you've added in your OpenAI token, otherwise it will not work. Okay, perfect. So back in our endpoints, we are now going to implement our WebSockets endpoint. So at the top, we're going to need a few imports. Firstly, we'll import JSON. For JSON handling, we'll also import logging for some logging. We can import time because we want to keep track of how long each request take. We can import base 64 as well. And then from fast API, want the API router. We want the WebSocket, and we also want the WebSocket disconnect. We also want to import OpenAPI, so we can say from OpenAI import OpenAI. We can also then import async IO for asynchronous operations. So import async IO. We've imported our settings configuration here. Then we have got our router and we're prefixing it with API v1. We can also initialize a logger for debugging and monitoring. So we can say logger equals logging.get logger and then pass name. And then we can create our OpenAI client with the API keys from the settings. So we can say OpenAI client equals OpenAI and then pass in our API key, which will come from settings dot OpenAI API key, like so. So the first thing we can do is accept the incoming WebSocket connection. Then after that, what we can do is we can open up a try except block like so. And in here, we can keep a connection alive and listen for messages using while true. And the first thing I want to do is wait for and receive a text message from a client. So I can say data equals await WebSocket.receive text like so. And then I'll open up another try except. So try except, put in a pass for now. And so in this try block, I can first parse the JSON message from the client. So I can say message data equals JSON.loads data. Once we have that, we can extract the user's message content. So we can say user message equals message underscore data dot get message, and that'll be an empty string. And we want to check if streaming is enabled. The default is true. So use streaming equals message data dot get, and then streaming, and the default is true. Message data spelled correctly. And so we want to validate the message is not empty. So we can say if not user message. We can then send an error response if the message is empty. So await WebSocket dot send text. And then we can do a JSON dot dumps. And in here, we can simply just put in a little error. No message provided. And then we can simply continue. So otherwise, if there is a message, what we want to do is we want to start a timer. So we can say start time equals time dot time. And again, we're doing that for performance metric tracking. And then we can call a function to handle our streaming response. So we can say await generate streaming response. And in here, we can pass in our user message, our WebSocket, and our start time. And we'll implement that in a sec, and we're just implementing it in another function just to break up our logic and to make our functions more modular. And so now for the first accept, we will check for JSON parsing errors. So JSON.JSON decode error. Put a dot there, JSON decode error. And here we can just send another text. So I can take this, and here we can just say invalid JSON format. And so then we'll also need to handle any other processing errors. So I can just copy that and then underneath paste it, and then accept exception as E. And then here in our error message, we can just say internal server error, like so. And then down here, well, we want to firstly handle client disconnection gracefully. So the first one will be WebSocket disconnect. And so here we can just say logger.info WebSocket connection closed. And then we'll need to also catch any unexpected WebSocket errors. So accept exception as E, and then logger.error WebSocket error, and then display the error like so. So now we've done our WebSocket, we now need to implement our generate streaming response function. So I'm going to take that, and then underneath here, I'm going to say async, it's an asynchronous function, and paste in the function name. So user message will be of type string, WebSocket will be of type WebSocket, and start time will be a float. So the first thing I'm going to do is open up a try block, add an accept down here, just pass for now. And so the first thing I want to do is I want to notify the client that streaming is starting. So I can say await WebSocket dot send text JSON dot dumps. So the type here will be streaming start, and the timestamp will be right now. So it will be timestamp will be time.time, like so. So once we have that, we can then create the OpenAI chat completion with streaming enabled. So we can say stream equals OpenAI client dot chat dot completions dot create, and then in here we can pass in our parameters. So first one will be our model. We are going to use ChatGPT 3.5 Turbo, GPT-3.5 Turbo. And then for the messages, we're going to send in an array. The first one will be our system message to define the AI behavior. So the role will be system And the content of the message will be, you are a helpful AI assistant, provides clear and concise responses. Something simple. Again, we're just demonstrating that we know how to interact with LLMs. And then we can also include a user message containing the actual user query. So here, the role will be user, and the content will be the user message, like so. Then after that, we are going to include the max tokens just to limit the response length. So max tokens equals 150. The temperature, so this controls the randomness. So 0 is very focused and 1 is very creative. We want to make it creative, so let's make the temperature 0.7. And then for stream, we want to set that to be true because we want to enable streaming for real-time responses. Next, what we want to do is initialize some variables to track the response. So firstly, it'll be full response, begins as an empty string, and then we also want to count our chunk. So chunk count will initialize as 0. So now we're going to iterate through each chunk that is returned from the OpenAI stream. So for chunk in stream, if chunk dot choices 0 dot delta dot content is not none, well, then we can extract the content from the chunk. So content equals chunk dot choices 0 dot delta dot content, and then we can append it to the full response. So full response plus equals content, and then we can increment our chunk counter. So chunk count plus equals 1. And then we can record the timestamp for this chunk. So chunk timestamp equals time dot time, like so. And then we can create a JSON message with the chunk data. So chunk message equals JSON dot dumps, and then the type will be streaming chunk. The content will just be the actual content. And finally, the timestamp will be the chunk timestamp. So timestamp will be the chunk timestamp, like so. So what we can do then is we can actually send that chunk via the WebSocket. So we can say await WebSocket dot send text, and this is going to be our chunk message. And then we can add a small delay to prevent messages batching on the front end. So we can say await async IO dot sleep, and we can make this very short, so 0.005. And I want to indent that to be inside the for loop and inside of our if statement, like so. And then finally, outside after the for loop, we can say response time. So we can calculate the total response time in milliseconds. So response time equals round. So right now, so time dot time. So this will be the end time minus start time. We will multiply by 1000 and then round to 2 decimal places. And then finally, we can send the final message with the complete response and metrics. So underneath that, we can say await WebSocket dot send text, again JSON dot dumps, and in here we can have an object. We have our type, which will be streaming end. We will have our response, which will be the full response. Response, like so. Oh, it's the actual variable, not a string. Underneath that, we can pass in our metrics as well. So metrics, the first one will be the response time in milliseconds. So response time ms, that'll be the response time. Then we will have our response length, and that is going to be the length of our full response. And then we have our word count, And so that will be the number of words. And so that'll be len full response. And then we want to split like so. And then as always, we want to handle any exceptions gracefully. So accept exception as E. We can say await WebSocket send text, and again JSON.dumps, and inside here we'll have a type which will be streaming error, and then the error message will simply be failed to generate streaming response. Perfect, so we can give that a save. And so we can open up our terminal here and do another curl request just to make sure our health check is still working. So next I want to redirect users from the home page to our chat page. And so we can use this in Next.js with a middleware file. So in our front end and in our source folder, get a new file called middleware.ts. So in here, I will import the next request and next response from next server. So import type next request and next response from next server. After that, I can create my middleware function. So I can say export function middleware. And here I can go request. This will be of type next request. And then underneath that, I want to check if the user is in the root path. So if request.next URL path name is just an empty slash, well, then I want to redirect to the chat endpoint. So return next response dot redirect, and this will be a new URL. It'll be chat, and pass in the request.url like so. And then we can simply continue with the request for all other paths. So return next response dot next. And then we want to configure which path the middleware should run on. So we can say export const config, and that is simply going to be on our home page. So matcher is going to be the / like so. Perfect. So now if I refresh on the home page, it should redirect us to the chat endpoint because we have set up our middleware. Perfect. And you can see there, I try to navigate to the home page and it instantly redirects me to chat. So we've got that redirect working perfectly. So next, what I want to do is create a reducer to handle message streaming on the front end. So a reducer is a pure function that takes the current state and an action as inputs, and it returns a new state based on the action type, ensuring predictable and centralized state management. And so the purpose of this reducer will be to manage chat message state with support for real-time streaming responses. So instead of adding complete messages all at once, it can progressively build AI responses chunk by chunk as they arrive from our WebSocket connection from our streaming OpenAI response. And so the benefits of using this reducer approach is first, we have predictable state updates. So all message modifications go through typed actions, immutable patterns, so safe state updates that work well with React rendering. And we also have type safety. So TypeScript ensures correct action payloads and state structure. So if I go into my front end, I'm going to open up my source here and I'm going to create a new folder called reducers. And in here, I'm going to create a message reducer. So message reducer.tsx. So firstly, we'll define the structure of a single message in the chat. So we'll say export interface message type. First, we'll have the ID, which will be a string. The text, so this will be the actual message content. So that will also be a string. Next, we'll have the sender. So this will be either the user or AI. So who sent the message? So sender. So it will be user or AI. For timestamp, that'll be a date, so when the message was created, date. And then for metrics, this is an optional performance metrics field that is only for AI responses. So it'll be metrics question mark to make it optional. We can say response time millisecond, and this is a number, so this is how long the request took. Then we have our response length, so this is the character count of the response. Response length is also a number. Then we have the word count, so the number of words, word count, number. And we're also going to have sentiment, so sentiment. And so that will be a string, which will be our sentiment analysis result that we'll add on later. We'll also have feedback. So that is optional, and it'll either be thumbs up, thumbs down, or null. So it will be a user feedback on the message. So thumbs up or thumbs down or null. And then finally, we can also have is streaming. So this is whether the message is being currently streamed. So is streaming, it's optional, and it's type Boolean. Cool. So next we want to define all possible actions that can modify the message state. So we can say type message action. So here, the first one will be of type add message. So type add message. And the payload will be of message type. So payload will be message type like so. And this will add a complete message. The next type will be the add streaming message. Type add streaming message, and this will not have a payload, and so this will initialize a new streaming response. Next, we will have our update streaming message, and this will append a chunk. So the type here will be update streaming message, so update streaming message. The payload will be a string, which will be the chunk. Let's just duplicate this line. The next one is going to be complete streaming message. So complete streaming message. So this is to finalize the streaming message, and the payload will be an object. It'll have text, which is of type string, which is the actual final complete text. And it'll also take optional metrics, which is message type metrics. So message type, and then metrics like so. And then I'm going to copy this, and our last type will be of set feedback. So set feedback. So this is when we want to update feedback for our message. And in the payload, it'll also be an object, but it'll take a message ID, which will be a string. So which message to update. And then the feedback will be of message type, but here it will be feedback like so. Give that a save. So we've got our message type and message action. So next I want to create the reducer function that handles all state updates. So I can say export const message reducer. And in here, it'll take two parameters. The first one will be the state, which will be of message type array, message type array. And then the next will be the action, which will be of message action type. Like so, and it'll return an array of message types. So next we are going to determine which action to perform. And to do that, we will use a switch statement, and we are going to switch over the action.type. So first case will be the add message. So this will be add a complete message to the end of a chat. So add message. And here what we're going to do is return an array. So we'll spread in the existing state and add the action payload. So spread in state and then add in the action.payload. The next case will be the add streaming message, which will initialize a new AI message for streaming. So case add streaming message. And here we again will return an array. We will pass in, spread in our state, and then we'll add in a new message. So the ID will be math.random.toString, like so. The text will be an empty string, so that's what we will start with. The sender will be AI. The timestamp will be a new date. Timestamp, new date. Is streaming will be true. And the feedback will be null for now. Feedback null. Like so. The next case will be the update streaming message. This will append a chunk of text to the currently streaming message. So here, case is update streaming message. So firstly, we'll say const updated state equals state dot map. So we'll map over it. So for each message, what we will then do is iterate through all the messages and append a new chunk to the existing text. So we'll say const updated message text equals the current message dot text plus the action dot payload, like so. So here we will use a ternary expression. So we will say message dot, if it is streaming, well, we'll check if it's a streaming message, and if it is, what we can do is we can return an object. So we can spread in the message and then update with new text. So text will be the updated message text. Otherwise, we will simply return the message, leaving non-streaming messages as unchanged because there will not be a chunk to add to it. And so then finally, what we can do is just then return our updated state. Next, we'll handle our complete streaming message case. So this will mark streaming as complete and set the final text and metrics. So underneath here, I can say case complete streaming message. And again, here, I'm just going to say return state.map, take the message. And here again, we will return based on if the message is streaming or not. So message.is streaming. If it is streaming, again, we'll update the new text. We will firstly spread in the message, MSG. So that will keep all other properties. We will set to the final complete text. So text will be action.payload.text. Really nice autocomplete there. Then we'll set is streaming to false because it's no longer streaming. And then finally for metrics, we can add them here. So we can say metrics action.payload.metrics, like so. And if it's not streaming, well, we simply return the original message itself. And then our final case at the bottom here will be of set feedback. So case set feedback. What we can do here is update the feedback thumbs up down for a specific message. So we'll go return state.map, take the message, iterate over it, and we want to find it by its ID. So that equals action.payload.message ID. Again, open up a ternary here. So if it is, we'll update the feedback. So we'll spread in all our existing message properties, and then we'll get our feedback, and that'll be the action.payload.feedback. And then if it's not, we just leave the message as unchanged. And then finally, what we need to do is handle our default case. So if it doesn't match any, we can just simply return the state, like so. Give that a save. So that is our message reducer created. Next, I want to hook up the WebSocket connection on the front end. So I'm first going to add some state as well as a use effect in our chat page. So I'll open up our app, go into our chat and go into the page. And so we're going to add a use effect hook. So this will establish and manage a persistent WebSocket connection to enable real-time bidirectional communication with the backend, and it'll handle the connection lifecycle. So open, close, error, and will route incoming messages to the appropriate handlers based on the message type. So streaming chunks, complete responses and errors, and it will automatically clean up the connection when the component unmounts to prevent memory leaks. So firstly, I'm going to make this a client component. So use clients because we are going to be using some hooks. So I'm going to say const messages dispatch. So this will initialize the message state using reducer for complex state logic. So dispatch. So this will come from use reducer, and we will pass in our message reducer, and it'll begin as an empty array. We'll also need some loading state. So const is loading, set is loading, use state false. Import that. And so this will be tracking the loading state while we're waiting for an AI response. And we'll also want to track the WebSocket connection status. So true if it's connected, false, disconnected, and obviously we'll start it as false. So const, we can just duplicate that and change it to is connected, set is connected. Perfect. Then we can store the WebSocket instance in a ref so it persists across re-renders without triggering re-renders. So const WebSocket ref is use ref, and we're going to pass in WebSocket or null, and it will begin as null, like so. So now that we have that, we can create the use effect. So beneath that, we can say use effect. And inside here, firstly, we'll create a new WebSocket connection to the backend. So we can say const WebSocket equals new WebSocket, and we'll pass in the URL. So it'll be WebSocket -- local host. Again, we're mapping the ports from our containers to our local computer /API/v1/WS for WebSocket. Then we can store our WebSocket in a ref for access in other functions. So we can say WebSocket ref dot current equals WebSocket, like so. And then we can have a handler. So when the connection successfully opens, we can say WebSocket dot on open, and here be a function. And inside here, we can say set is connected is true. So update that piece of state. And now we'll create a handler for all incoming messages from our server. So we'll say WebSocket dot on message. So here we'll get our events. And firstly, we'll parse the JSON data from the server. So const data equals JSON.parse, and we'll pass in the event.data. We will first handle if we get an error response from the server. So we will say if data.error. We will need to create a error in the chat. So I'm going to create a new handler called add message. So if I go above it here, this is going to be a helper function to add a complete message to the chat. So const add message. So it'll take text, which is a string, a sender, which again will either be user or AI, and it will take an optional metrics, which we can lazily just type as any for now. And so here we're going to send an action to the reducer using dispatch. So dispatch, so the type will be add message, and then we need to send the correct payload. So the ID will just be math.random.toString, like so. After that, we'll send in our text. So that will be the message content. We'll send in the sender, so who sent it. We'll also send in a timestamp, which will be just right now. So new date, sender. And then after that, we will put in our metrics, which are optional, and the feedback will be null for now because we will initially have no feedback. So feedback is null. Cool. Now that we have that in, if we have an error, we can say add message. We can have error, and we can do some string concatenation here. So dot error, and then this will be from the sender, who is the AI, and then we can set is loading to false. Cool. Next, we'll handing streaming initialization message. So else if data.type equals streaming start. So here we're going to add a streaming message. And so again, I'm going to come above and create a new utility function. So we'll say const add streaming message. This will not take any parameters, and we will dispatch the add streaming message type. So the type will be add streaming message, like so. And so down here, I will simply say add streaming message, and then set is loading to false as well. Cool. Underneath that, we will handle individual streaming chunks arriving in real time. So else if data.type equals streaming chunk. Well, then what I want to do is I'm going to update our streaming message. So again, up here, a new utility function, const update streaming message. So this will take content, which will be a string, as a parameter. And then in there, we will dispatch an event, which will be of type update streaming message. And we need to include the payload, which will be a string, in this case, the text chunk, which is represented in the content. So then down in our streaming chunk, we can say update streaming message and pass in our data.content like so. Next, we want to handle streaming completion with full text and metrics. So else if data.type equals streaming end, we can say complete streaming message. Again, it'll be a new utility function. So up here, const complete streaming message. It will take the full response, which will be a string, and then the metrics, which we will lazily type as any for now. And then in our function body, what we'll do is we will dispatch another event. Again, same thing, type will be complete streaming message, and the payload will be an object where our text will be the full response, and our optional metrics are included like so. So we now need to call that function whenever the streaming end event is received. So complete streaming message, and we will send in the data.response and the data.metrics like so. And then finally, we need to handle complete non-streaming response fallback. So else if data.response. So if we get that, we want to add a message, which will be data.response. It'll be of AI, and we'll also pass in data.metrics like so. And then set is loading to be false. So once we've done that, we need a handler when the WebSocket connection closes. So WebSocket.onClose. And in this handler, we will simply say set is connected is now false. And then finally, we'll need a handler when WebSocket encounters an error. So WebSocket.onError. We'll take the error as a parameter. And then we will say set is connected is false. Don't have any error state for now, but we could easily add that if we wanted. And then we'll also add a cleanup function to close the connection when the component unmounts. So we can say return. And in here we can say WebSocket.close like so. And we will have an empty dependency array as we only want to run this once on mount. So if I give this a save, if I go over to our app, if I open up the network tab and I go to socket, I reload the page, you can see here in our WebSocket, we have successfully connected to our backend. All Tailwind. So let me open up a terminal, CD into the front end, and then I'm going to install Tailwind CSS, PostCSS, and PostCSS. Okay, now that I've done that, I'm going to go to the PostCSS file, and instead of an array, I'm just going to turn it into an object, like so. Give that a save. And then if I go back to our page and I come all the way down to our chat, I'm going to add a class name and just text blue 500, just see if it's working, give it a save. And you can see here our chat text is now blue, so we've now successfully hooked up Tailwind. So next we are going to create the chat header component, and this will be the component to display the app title and the connection status. So in our source folder in our front end, I'm going to create a new folder, components, and the first one will be a chat header. So new file, chat header.tsx. And so first I'll create an interface. So interface chat header props. And firstly, it's only going to start off by taking is connected, which will be a Boolean. Then underneath that, we can say export default function chat header, if I can spell function. And that will take in our is connected, and that is of type chat header props. And then this is a very simple UI component. Firstly, it'll return a div. This will be a header container with a dark background and bottom border. So here we'll say class name, BG slate 800, border B, border slate 700, and we'll give it a padding of 3. And then for small screens and above, we can give it extra padding of 4. Then we can add our app title with responsive text sizing, so smaller on mobile and then larger on bigger screens. So I can add in a H1 here, add in a class name, and so text LG, and then for small screens and above it can be text XL, and then the font can be semi bold, and it will be text slate 200 like so. And in here we'll just put in chat app for now, and then underneath this we can put in our connection status indicator row. So we can put in a div here, class name of flex, items center, and give it a margin top of 2. And then in here we can add the status dot that changes color based on the connection state. So div, and then in here for the class name we'll use string templates. So width 3h3 rounded full mor2, and then in here for our variable coloring we can say is connected, and then we can have a ternary. If it is connected we'll say bg green 500, and if it's not it's bg red 500. So green if connected, red if not. And that'll be a self-closing div. There's no content. And then underneath that we have the connection status text, so we can add a span here. Class name will be text small, and text slate 400, text slate 400. And we can have is connected, and if it is connected we can just have connected, and if it's not connected we can say disconnected like so. So now we've got our chat header function. We can go into our page, and here at the top what I can do is I can add in that chat header component, add the import, and then we need is connected, prop is connected, and then underneath that we can just add a body. We can change this class name now, so we'll make it flex call. The H will be the height of the screen, and we'll give it a dark background, so bg slate 900 like so. Give that a save, go over to our app, and as you can see there we've got our nice chat app header, status is connected, and we have our dummy body component. So nice, we've added the header. So the next component I want to add is the message input. So if I go over to our components, I'm going to create a new component called message input.tsx. And so here what I'm going to do is firstly again define our interface. So interface message input props. So here we've got our input message, which will be a string. Underneath that we have our set input message, which will be a function which has a message parameter of type string, and it will return void. So that'll be to, of course, update the input message. We will have a send message, which will be a function to send a message, and that'll be a function which doesn't take any props and returns nothing. We'll then send in the is connected state Boolean variable, as well as the is loading Boolean variable like so. So now we can actually define that component that will render the message input area at the bottom of the screen. So we can say export default function message input. So again, it'll be input message, I'll spell it correctly, input message, set input message, send message is connected and is loading, and that'll be of type message input props. So the first thing we're going to do is define a function to handle keyboard shortcuts in the input field. So we can say const handle key down. So this will take an event which will be of type react.keyboard event. And if the enter key is pressed without shift, we'll send the message. Otherwise, shift enter will create a new line. So if e.key is enter and bang e.shift key, well, then we will prevent the default behavior, which is a new line, and then send our invoke our send message function. And now what we can do is return our component. So here we'll add our outer div, and in the class name, again, this is going to be a fixed position container centered at the bottom of the screen. So fixed bottom 4, left a half, and then we're going to transform and then minus translate x a half, like so. Give it width full, a max width of 2xl, and padding x of 4. And so that's just going to center it at the bottom first nicely. Then we're going to create our input container with a dark background and rounded corners. So in here, another div. So bg slate 800, add in a border slate 700, rounded 2xl, give it padding of 3, and then also give it a shadow and a large one, which will be nice. Now we'll add our flex container for the input and button. So div class name, so we'll go flex space x2. Now we'll add our text input field. So in our input, first will be our type, which will be it is of type text. The value will be the input message. For our on change, we can take our event and we can say set input message e.target.value. For on key down, we can pass in our handle key down method. For the placeholder, we can simply say type your message ... And then the disabled, so we'll disable it if it's not connected or if it is loading. So disabled bang is connected. So if it's not connected or is loading, we will disable it. And then we'll add a class name. So we'll add flex1 px3 py2, and then on small screens and above we'll add some more px4, and then we'll have text sm. Above small screens we'll have text base, and then we'll add on a border slate 600, add some rounding, so rounded lg, so some border radius. We'll add a focus state, so focus outline none. We'll add a ring, so focus ring 2. Then we need to color it, so it'll be focus ring purple 500. Then we'll add a disabled state, so opacity will be at 50. Now we'll add the regular, so bg background color will be slate 700, text slate 200, and finally we'll add a placeholder slate 400, just so it's more discreet. And beneath that input, we will then add our send button. So this button, a few attributes. First one is on click. So first one is send message. So this will be the trigger to send on click. For disabled, again, probably turn this into a variable, but it'll be if it's not connected or is loading, or we have no input message. So if we trim it, so input message dot trim. So if that is no characters, that'll be falsy. So then it's disabled if we haven't typed anything. And to save time, we'll just add some nice styling onto the button there. Again, similarly adding some colors and some focus ring. And then for the actual text, I will have a span. In the class name, I will have hidden for small screens, and then above small screens it'll be inline, and that'll say send. And then we'll duplicate it, but then we'll reverse it. We'll say above small screens, this one will be hidden, otherwise it'll be inline. And this will just simply be a little arrow just to save space on smaller screens, like so. So if we go back to our page, we need to set up our state to keep track of the input message. So up here, I'll say const input message set input message equals use state, and that'll just be an empty string. And then we'll need a function to handle the complete message sending process. So I'll say const send message, won't take any parameters. And then in here, we'll first remove leading, trailing white spaces from the input. So const trimmed equals input message dot trim. So we'll early exit if the message is empty, we're not connected, or we're loading. So if it's an empty string, or we're not connected, or is loading, well, then we will simply return. Otherwise, we'll call a dispatch event. So dispatch, the type will be add message. And then the payload will be an object. The ID will be math.random. That's toString. The text will be our trimmed text. The sender will be the user. And the timestamp will be a new date. So right now, and then the feedback will be null because we have no feedback initially. Once we've done that, we can set our input message to be an empty string. So we'll reset that. We can set is loading to be true because we are now waiting for the AI response. And then we can send the message to the backend via the WebSocket. So we'll use the ref, so WebSocket ref dot current dot send. And in here, we are going to JSON.stringify. And in here, we are going to send our message, which is trimmed, and streaming, which is set to true because we want the response streamed back. And so then at the bottom in our component, I can get rid of underneath this body part. I can put in our message input. And now we need to add our missing attributes. So the first one we need is input message. So that will be input message, set input message, set input message. Send message will be send message. The function we just created is connected, is connected. Now you could use context here if you wanted, but because we're not passing these props to many components, there's no real need. But if this app was larger, for sure we'd want to add these pieces of state to a context. So is loading, is loading, like so. Give that a save. Now if I go back over to our app, you can see we have our message component. So now if I refresh, we should see our WebSocket connection. And then if I go into messages, I should then be able to type a message and then click send. So you can see our first message was sent, and then we're streaming from the server all the chunks first, because again, we're streaming. So it's hello, how can I assist you? And then at the streaming end, we've got a response, hello, how can I assist you today? So perfect. We are now sending and receiving streamed responses from the back end to the front end. So the next thing I want to do is obviously show these messages. So what I'm going to do is open up a new terminal, and I'm going to cd into the front end, and then I'm going to install React Markdown and remark-gfm. And so React Markdown libraries for rendering Markdown syntax. And then we are also going to import a GitHub flavored Markdown plugin for tables and code and other features like that, which we're going to be displaying. So we can close that, and we can go back over to our components, and we can create a new one called message.tsx. And again, we can import message type from reducers, message reducer. We can then also import React Markdown from the package React Markdown from React Markdown, like so. And then we need remark GFF, so import GFM from remark GFM. Next, we'll define our interface, so interface message props. Okay, what's it going to have? It's going to have a message type, message type, and now we'll define the component that renders a single message with the Markdown support. So export defaults function message. We'll take one prop, which is a message, and this will be of message props type. Now we'll return our component, so it'll be a div. Firstly, we'll have a class name. first it'll be flex, and then based on the type of user, so we can say message.sender, that is a user. Well, then what do we want? We want to push it to the end, so to the right hand side of the screen, so justify end. Otherwise we want it at the start because it's an AI, so justify start. And then we also want the message bubble with responsive width and conditional styling. So inside here, add another div. So I'll give it a max width of 85%. Above small screens, it'll have a max width of extra small. And then above large screens, it'll have max width of medium. We'll give it padding on the X of 3, padding on the Y of 2, and above small screens, we give padding on the X of 4, and padding of the Y of 2. We'll give it border radius large, and slimmer enough, we could check the message sender is a user. Again, we could put this into a variable, but it's not the end of the world if we don't. So if it is, well, we want to change the color, so it'll be BG purple 900 and text is white. But if it's from the AI, we'll change that, so it'll be BG slate 800 with an opacity of 60, and then text slate 200, like so. So next we want the message content container with responsive text sizes. So inside here, I have another div, and this one will have class name. Again, it'll be text small, and then on small screens and above, it'll be text base. So just adapting for the size of the screen. Now we'll have our React Markdown component to parse and render Markdown. So React Markdown. So firstly, for our remark plugins, we are going to be using the remark GFM, like so. I'll put it into an array. Now we want to pass in our components because we want to custom render for code blocks. So components. In here, I'm going to say code. It'll take a node, class, name, children, and props. And so first we'll check if this is a fenced code block with language specified. So I can say const match, use some regex, so language -w plus and then /.exec class name empty string. So this extracts the language name from a class name string that matches the pattern language-name. So for example, it'll extract Python if it's from language-python. And so if the language is specified, we can render as a code block. So we can then say return. So if it is a match, return a div class name my2, give it some border radius and then overflow hidden. And then inside that, we can give it a header showing the programming language. So class name will be BG slate 800 px 3 py 1. Text will be extra small, text slate 400. Give it a border on the bottom and a border of slate 700. And then in here we can just simply put in the first match, so match 1. And then underneath that we can actually add in our code snippet. So we will use the pre-tag, and for the class name we'll give it a BG slate 900, so slightly darker, padding of 3, text will be small, text slate 200, and overflow X auto, so you can scroll on the X axis. And then in here we will have a code where the class name is the class name being passed, and then we can spread in the other props and then pass in the children, like so. However, if it's not a match and there's no language, we can render as inline code. Put that in some braces, and then here we can just in a regular code, class name BG slate 800 px1 by 0.5. Give it some border radius and small text. We can spread in the props as well here. And finally, we can pass in inline code content from the children. So that's for code. Next, we can add in a table. So table, take the children. We can return a div here. In the class name here, we can have my2 overflow x auto. The wrapper will allow horizontal scrolling. In here, we'll add a table component, table tag. Class name, very simply, will be min width full. Give it a border slate 700, and we'll also give it some border radius like so. And here we will render the children, which will be the table rows and cells. And then underneath this, we will have a custom renderer for table header cells. So th, again, take the children, and we will return a th tag. And then just to save time, we'll add in our styling like so, and then simply render our children. And then we'll do the exact same for the table cells, again, using the TD tag. Then we'll add our paragraphs here. And all we're doing here is we're breaking words. We're adding margin below each paragraph, except on the last one where we will not have any margin on the bottom. We'll then have a custom renderer for unordered lists. And here we'll just have a disk. And then for ordered lists, we'll simply make them decimal, so they're numbered. We'd also want block quotes. So again, this is for if you wanted to have a quote, and all you're doing here is essentially adding a border on the left. So if you look here, basically we've got our border left, and then we basically change the text to be italic. And then we'll have custom renderings for all of our headers from heading 1 to heading 6. And the only real difference here is basically the text size. So it goes from extra large all the way down to extra small. And then inside our React Markdown, what we actually want to render is the message.text. So this is the actual message content to parse and render. So underneath that, we want to show a pulsing cursor indicator if the message is currently streaming. So here we'll say message.is streaming. If it is, we will show a pulsing line. Otherwise, we will show null. Give it a save. And then finally, we want to show the timestamp showing when it was sent. So here we can add a paragraph tag, give it a class name, text extra small, opacity will be 70, and there'll be a margin top of 1. And in here we can say message.timestamp, and this will be to locale time string. And so this will format time in the user's locale. Give that a save. Next, I'm going to create a loading indicator component so that we know when a message is loading and we haven't received any chunks. So loading indicator.tsx. So here I'll say export default function loading indicator. And so here we want the outer container line to the left. So same as the AI messages. So div class name flex justify start. Then inside that, we want the loading bubble styled like an AI message. So div class name, dark background. So BG slate 800. Give it a border slate 700. The text will be lighter, text 200. Give it some padding on the X and some padding on the Y, and make it rounded. Then want a container for the 3 bouncing dots. So here, inside this div, class name, flex space x1. And then inside that, the first dot, second dot, and third dot. So the first dot, self-closing div, we can say class name, width to h2 bg slate 400. Rounded full, so it's like a circle, and animate bounce. And then we can duplicate that twice. Now you could turn that into its own component. And then for the second and third, we're just going to add a slight delay. So style will be animation delay 0.1 seconds. Actually, we'll duplicate that, get rid of this, and then we'll change that delay to be 0.2 seconds. So that gives you that nice kind of sequenced bouncing. Give that a save, and then we'll go back to our chat page. And so we need to create a ref to track the invisible div at the bottom of a message list. So up here, underneath our WebSocket ref, I can say const messages and ref equals use ref. This will be of type HTML div element. It'll begin as null. We'll also want a function to scroll to the chat view to the bottom. So const scroll to bottom. So here I'm going to say messages end ref dot current dot scroll into view, like so, and the behavior will be smooth to give it that nice smooth transition. And then we'll add a use effect, and in the dependency array will be the messages, because we want to rerun it when the messages change. And then we will simply, whenever our message change, we want to then invoke that scroll to bottom function, like so. And so then down in our component, get rid of this placeholder body. In here I can say class name, and this is going to be the scrollable middle section containing all messages. So it'll be flex 1 overflow y auto p some padding of 4, and then padding bottom of 24. So giving us enough room at the bottom so that the input isn't stacking on top of any messages. And then we want a container for messages with max width and centered. So in here we'll have a div, class name will be max width to XL, MX auto space Y3, and then above small screens we'll add a bit more spacing on the Y, space Y4. And then inside here we want to loop over all messages and render each one. So we can say messages dot map message, and then for each one we want to return our message component. So import that. Again, it's a list, so you need to add a key so it can render properly. Message.id, and then the message will be the actual just message itself. Cool. And then underneath that we can have our loading. So we want to show the loading state when waiting for AI response. So is loading, then we put in our loading indicator, otherwise null. And then beneath that we want our invisible div at the bottom of the messages to target for auto scroll. So we'll have a self-closing div, and it'll have a ref which will be the messages end ref, like so. Give that a save. So if we go back over to our app, I can now type test message. Let's see if we get a response. We get the nice loading state, and boom, we're getting our streamed response back. Perfect. And you can see we've got our messages appearing on the right, AI response appearing on the left, exactly like what you'd expect in an AI chat app. So now that we've got that, the next thing to do is to support image upload. So now that we've implemented messages, it's time to implement image upload. So what we're first going to do is add a fast API endpoint that will handle these image uploads. And it will also use AI-powered visual analysis using OpenAI's Vision API. And so it'll access an image file along with an optional text prompt. It'll convert the image to base64, validate the format, and send it to OpenAI for analysis, returning a detailed description or custom response based on the user's request. So let's do that now. So if I go over to our endpoints, so I'm going to go up to the top and update our imports. We are going to want upload file, and form, as this will be used for our upload image function. So now I'm going to define a post endpoint for image upload and analysis. So at router.post, the endpoint will be upload image. This will be an asynchronous function, so async def upload image. First parameter will be a file, which will be of type upload file, like so. And then the second parameter will be a message, which will be of type string. form. So now we'll open up a try except block, accept, pass. And so the first thing I want to do is I want to read the uploaded image file as bytes. So I'll say image data equals await file.read. Once I have that, I want to convert the image bytes to a base64 string for API transmission. So image base64 equals base64 dot base64 encode. We'll pass in our image data, and then we'll decode UTF-8. UTF-8. Perfect. Then we'll get the MIME type from the uploaded file. So we'll say content type equals file.content underscore type, like so. And then once we have that, we are going to determine the image format based on the content type. So if content type equals image slash JPEG, well then it'll be JPEG. So image format equals JPEG. And then we can simply repeat that for all the other types. So instead of if, we will use elif, and instead of next one, it'll be PNG, PNG, and then we'll copy that and duplicate it here for GIF, GIF, and the last one will be for WebP, so image WebP, spell GIF properly, WebP, and then otherwise we'll return an error if the format is not supported. So else return error unsupported image format. So next what we will do is we will create a prompt based on whether a user provided a message. So we'll say if message and message.strip. So if it's not an empty string, the prompt will be a formatted string like so. First thing will be the stripped message. So message.strip. Then we'll add some new lines, and then we can say, please analyze the image and respond to the user's requests. And so the else case will be if there's no user message, and so we'll use a default detailed description prompt. Down here, I can say else. The prompt will simply be, please describe the image in detail, what you see, include any text, objects, people, colors, and overall scene description. So now that we have this, we can then call OpenAI's Vision API with the image and prompt. Create a bit of space here. I can say response equals OpenAI client dot chat dot completions dot create. The model will be GPT-4o, and our messages will be an array. The first object will be a role of user, and again the content will be an array where the first object will be the text and image. So type will be text, and the text will be the prompt like so. And then the second element is the image itself. So let's create a new object, type image URL, and the image URL will be the data URI with base64 encoded image. Image URL. So URL be again another formatted string. So data image, and then we'll put in our image format, and we will have base64 and comma, and then we'll include our image base64 like so. And then beneath our messages, we will finally have a max tokens of 300. So max tokens equals 300. And this will limit the response to 300 tokens. So underneath that, we can then extract analysis text from OpenAPI response. So analysis equals response.choices 0.message.content. And then finally, we can return a successful response with analysis and metadata. So underneath that, we can return an object. Success will be true. Analysis will be analysis. We then want the file name, so this is the original file name. So it will be file.filename. We'll have the content type, so the image MIME type. Content type will be the content type. And then we'll also have the user message, so the user's optional message. So user message is the message. And then finally in our except, we want to handle any errors during image processing. So handle exception as E. And then in here, we simply want to return error and another formatted string here. So failed to process image. And then we can passing a string of the error. So now that we have that in the back end, we want to implement it in the front end as well. So if I go to my chat page, at the very top, the first thing I want to do is add some state to track whether an image is currently being uploaded. So I can say const is image uploading, set is image uploading, use state, and the default will be false. So next we want to create a function that handles the complete image upload process. So this will be called handle upload. Underneath our use effect here, I'll say const handle image upload. It's an asynchronous function that takes a file of type file and a message of type string. So we want a guard clause, so we want to exit if no file exists, we're not connected, or are already loading. So if not file, or we're not is connected, or is loading, we simply return. Otherwise, we'll validate the file was actually an image. So if not file.type starts with image slash. So if it doesn't start with that, well, we know it's not an image. So we can just simply do a quick alert here. Again, you could do something nicer like a toast if you had more time. So please select an image file. And then we can return. And then we also want to validate that the file size is under 10 megabytes. So if file.size is greater than 10 times 1024 times 1024. Well, again, another alert. Image size must be less than 10 megabytes. And then again, just return. So now we want to set the uploading state to true so that we disable input during this time. So set is uploading image to be true. Next, we want to create a form data object to handle multi-part form data submission. So const form data equals new form data, like so. And then we can append the image file to the form data with that key file. So form data dot append, and so file, and we'll be appending on the file itself. Underneath that, if the user provided a message, we can add it to the form data. So if message.trim, well, then we can append it on. So form data dot append message, and it will be the message.trim, like so. And so now that we've done that, we can actually try to send to our backend. So I can say, open up a try, catch E, just leave it empty for now. We'll handle that later. So in the try, we can send a post request to our backend image upload endpoint. So const response equals await fetch. And then in here, we can put in our endpoint. So HTTP localhost 8081/API/vwall and /upload image. Now, obviously, you would store this in an environment variable, and you could reuse this in a constant variable because we're now using this base URL in two places, but I'll leave that up to you to do. And again here, the method will be posts, and our body will be the form data like so. So if the response was not okay, response.okay, well, we then want to throw new error, failed to upload file. Otherwise, we want to parse the JSON response from the backend. Const results equals await response.json. And then we want to create the user message text to show the message if provided. Otherwise, just show image uploaded. So const user message equals message.trim. And so if that exists, so it's a non-empty string, so then we can use the actual message provided, so message.trim. Otherwise, we can just put in a placeholder image uploaded, like so. We then want to add the message to the chat, so add message, user message, and it's of type user. We want to add the AI's analysis response to the chat, so add message, results analysis, and that will be of type AI. And then in our error block here, we can simply show another alert, failed to upload image, please try again. And then we can also add on a finally here. And so in here we can set is image uploading to be false, because we can always reset this regardless of success or failure. So now that we have that, I want to update our image upload, our message input component. So here is loading will now also be based on if the image is uploading. And then I also want to add on a new prop on image upload. And this will take our handle image upload function. So I now need to add this to our message input. So save this, go to our message input. So let's update the interface. So on image upload, and this will be a function which has a file and a message, which is a string, and it will return a promise void arrow. Perfect. And then we want to add that from our deconstructed props here. So on image upload, perfect. Now I want to add two pieces of state. The first will be a state to store the selected image file object. So here I'm going to say const selected image set selected image use state file null, import use state from React, and then also create a state to store the base64 preview URL for displaying the thumbnail. So const image preview set image preview equals use state, and it'll be either string or null, and the default will be null like so. So now that we have that, I want to create a handler when a user selects an image from their file input. So const handle image upload. I'll take an event, which will be a React change event from a HTML input element. And then in here, the first thing I want to do is get the first selected file from the input. Const file equals event.target.files 0. I then want to exit if no file was selected. So if not file, simply return. Next, I will store the file object in state. So set selected image be the file. And then I will create a file reader to convert the image to base64 for preview. So const reader equals new file reader. Set up a callback for when the file is read. So reader dot, update that to be reader. So then it is reader dot onload. This will take an event. And so here I can say set image preview e.target.result, and we can cast that as string. And then we can start reading the file as a data URL, so base64, so reader.read as data URL, pass in the file, and then reset the input value to allow selecting the same file again. So events.target.value is now an empty string. So now that we've that done, I want to create a new handler, and this handler will be used to send the selected image with the optional text message. So const handle image send will be an asynchronous function, takes no parameters. And firstly, we'll exit if no image selected, we're not connected, or it's not loading. So if bang selected image or bang is connected or is loading, we simply return. Otherwise, we'll get the trimmed text message. It may be empty, so const message equals input message dot trim. Oh, just trim. And then we'll call the parent function to upload the image and message the backend. So await on image upload. What are we sending here? The selected image and our message. We will then clear the selected image after it's been successfully sent. So set selected image to be null. Also clear the preview. So set image preview will also be null. And then we will also clear the text input as well. So set input message to be an empty string. And then lastly, our last handler we will need will be a handler to remove the selected image without sending. So const remove selected image. And this will pretty much do what we did before. We will just take our two pieces of state and reset them like so. I also wanted to define a variable called isImageMode. So this will be a Boolean flag to track if we're currently in image mode, i.e. we have an image selected. So const isImageMode equals selected image is not equal to null. So then in our component, what I can do now is just open up some space, put in curly parentheses, and I'll go if there is an image preview. What we can then do is we can open up a ternary. If it doesn't exist, display null, but if it does, we can add in a div here. Class name. So this will be the container. So we'll give it a margin bottom of 3, a padding of 3, a background slate 700, and some border radius. Inside that we'll have a header row with the title and remove button. So div class name. So this will be a flex items center justify between an MB2 margin bottom 2. We'll then have our selected image text, so span class name, so small text SM font medium text slate 200. And then in here I can just go camera image selected, and then underneath the span we'll have a button, and this will be to remove. So here we'll say on click equals remove selected image, and then a class name, so text red 400 over text red 300 and text small as well. And here we'll just have text to remove. So underneath that we'll have our preview row with the thumbnail and file details. So add a div here, class name, so flex items center space x3. Now we'll have our image thumbnail, so it will be an image tag. The src will be the image preview, so that's the base64 preview URL. Then we'll have the alt will just be preview, and then we'll add in just a class name here. So give it a width of 12, a height of 12, object cover, rounded border slate 600. And so what object cover is doing is it is resizing an image to cover its entire container while maintaining the aspect ratio and cropping the overflow if necessary. And then beside that, we'll have another div. And this one will contain the metadata. So class name, flex1, and then underneath that we'll have a paragraph tag. Class name will be text extra small, text slate 400, and it'll be the selected image name. So selected image name, and then we'll also include the file size in megabytes rounded to 2 decimal places. So we will have another one of those to be 300, and here it will be selected image dot size, and we'll fall back to 0, put that in braces, and then or divide that by 1024 divided by 1024, and then round it to 2.2 fixed 2. Add another parenthesis there, and then add in our megabytes like so. Perfect. Give that a save. Now down here underneath this SpaceX2, I will add in our label. So this will be the file input button styled as a clickable label. So label, and here we're just going open it up and basically add in a load of classes here. So it's just giving it some padding, styling the text, the background, and then giving it no outline and a focus ring depending on its state. And then in here we'll add an input. Type will be file. The accept will be an image, so only allow image files. On change will be handle image upload, and then it'll be disabled if we're not connected or is loading. So if it's not or is loading, well then it's disabled. And then finally we'll hide the native file input, and the label is in the UI, so we'll say class name is hidden. And then underneath that, we will just have a span, and we will just put in an image like so, a little emoji. So same on mobile and desktop. And then lastly, we now need to update our button logic to handle is image mode. So on click, we're going to check is image mode. If it is, we'll then call handle image send. Otherwise, we'll just do our regular send message. And then here we will update our disabled state. So it'll only be disabled if we're not in image mode and there's no message. So if there's no message and we're not in is image mode. And then here for our actual messages, we'll check is image mode. If it is, we'll have it to be send image. Otherwise, it'll simply be just send like what we previously had. And then exact same thing here is image mode. If it is, we'll add our camera emoji. Otherwise, we'll just default to that arrow icon on small screen. So if I give that a save now, so let's go back over to our app. So I'm now going to click on the image icon. I'm going to choose in this case an image of a cat, and you can see here we have our nice display here. If I click remove, it removes it. You can then re-upload it. And then I'm going to say just send it without any message. And perfect. On the back end, if you remember, if there was no message, we added a system prompt just to generally describe it, and that's exactly what it's done. And if I upload the same image and I say, what color is the cat? That should give us a response. Perfect. The cat is orange with white markings. Perfect. So we've now added image upload functionality. Okay, the next piece of functionality we need to implement is sentiment support. So this will basically be classifying a response from the AI as either positive, negative, or neutral, as this was outlined in the requirements. So what we're going to do is implement a two-tiered sentiment analysis for our AI responses. So we'll have a sophisticated GPT-powered analyzer that understands the context, and we'll also provide a simple keyword-based fallback if the API call fails. And so this provides insight into the emotional tone of the conversation and can be used for metrics, monitoring, or improving the user experience. So let's go back to our endpoints, and then in our generate streaming response function, what I want to do is underneath word count in our metrics, I'm going to update this. We're going to add sentiment. And this would be await, analyze sentiment, complex, and we're going to pass in the full response here. So we now need to implement this function. So if I go down here above our upload image, I'm going to say async def analyze complex sentiment, and that will take text, which will be of type string, and it'll return a string as well. So we'll open up a try except pass for now. And then inside the try block, we will call GPT 3.5 Turbo for sentiment analysis. So we'll say response equals OpenAI clients.chat.completions .create. Model will be GPT 3.5 Turbo. And then for the messages, that will be an array where the first one will come from the system. So this row will be system, and then in here I'm going to add a system prompt. And so this is basically telling it to analyze the sentiment of the following text and consider the context and tone, the sarcasm and irony, the mixed emotions, cultural context, and politeness versus actual sentiment, and respond only with one word, positive, negative, or neutral, and be conservative. If unsure, simply choose neutral. And then after that, what I can do is I'll add another one, and this will be the user's content. So role will be user, and the content will be the text. Then underneath that, we will set max tokens to be 5 and the temperature to be 0.1. So very low temperature for consistent deterministic results. And we only need one word, so we will limit the maximum number of tokens as well. Then underneath that, we'll extract the sentiment. So sentiment equals response dot choices 0 dot message dot content dot strip dot lower. So this should be our word. So if positive in sentiment, return positive, and then we simply repeat that. So elif negative in sentiment, return negative, otherwise just return neutral. And then in our exception here, as exception as E, we can then return analyze sentiment simple, and we'll pass in our text. So then underneath here, we'll create this function. So here it'll be def analyze sentiment simple. That'll take text string and it'll return a string. So we'll have a list of positive words, and then we'll also have a list of negative. We'll convert the text to lowercase for case insensitive matching. So text lower equals text lower. Then we'll do both a positive and negative count. So we'll say positive count equals sum 1 for word in positive words, if word in text lower, and then we can simply repeat that. So negative count equals sum 1 for word in negative words, if word in text lower. And then very simply, we'll just compare the numbers. So if positive count is greater than negative count, return positive, and that will be a string. And then elif the reverse, negative count is less than positive count, return negative, and then otherwise return neutral, like so. Give that a save, get rid of these issues here. Perfect, give that a save. So now that we have that, we can define a message metrics UI component so that we can show that for each response from the AI. So if I go back over to our front end and components, I'm going to create a new file called message metrics.tsx. And as always, I'll define the TypeScript interface for the component prop. So interface message metrics props. The metrics will be an object. So we've got the response time in milliseconds, so that'll be a number. We have the response length, that'll be a number. We have the word count, which will also be a number. We have the sentiment, which is a string, and a message ID, which is a string as well. So now we will define the component that displays the metrics below each AI message. So export default function message metrics. This will take the metrics, which will be the message metrics props interface. First, we'll define a helper function to determine the text color based on the sentiment. So const get color, and this will take the sentiment, which is a string, and it will be a switch over the sentiment. If it's positive, return text green 400. If it's negative, return text red 400. And then finally, the defaults will be return text slate 400 for anything neutral. And then after that, we also want a helper function to get the emoji icon based on the sentiment. So const get sentiment icon. And again, it'll take the sentiment as a string. And essentially, I can literally repeat the exact same thing here. We've got positive, negative, and our default neutral, just showing different faces for each one. So now that we have that, we can actually build out our component. So I'll say return. We'll have an outer div container. So that'll have a margin top of 2, padding top of 2, a border top, and a border slate 700. We'll then have a metrics row. So here, class name will be flex, item center, give it a gap of 2, justify between, give it text extra small, so small text, and then the text slate 400. Inside that, we'll have the left side. So this is all metrics in a horizontal row. So I'll have div, class name, flex, items, center, space x2. Then we'll have the emoji in a span. So span, get sentiment icon, metrics dot sentiment. And then we will get the actual sentiment text with the color coding. So I have a span. For the class name, I will simply pass in the result of the get sentiment color, and we'll pass in the metrics dot sentiment, and then inside it we'll actually show the sentiment itself, metrics dot sentiment, like so. Underneath that, I want to show the response time in milliseconds, so span metrics dot response time milliseconds. Add in our milliseconds like that, and then we also want to show the word count, and then we can just say words like that. Give that a save. So then I can go over to our message component, and at the very bottom, I'm going to open up some space here. I'm going to conditionally render. So if the message dot sender is AI, and there are message metrics, and it's not streaming, so it's been completed, well then what we'll show is our message metrics. So I'll open up that. If that condition fails, we'll display null. But in here, we'll say message metrics. And we'll add in our missing parameters. So the metrics will be message dot metrics. And we'll need a message ID, which will simply be the message dot ID. Need to make those curly braces. Give that a save. So if I go back over to my app, I'm going to tell it to write a positive sentence. So for our sentiment analysis, then we would expect it to be positive. And then here, perfect. You can see we've got our emoji, the coloring of the text. You can see in milliseconds and the number of words, and then say, write a neutral sentence. And then perfect, we've got neutral there as well. So perfect, we are now doing our sentiment analysis. And so the last thing I want to do is to be able to add feedback. So a user can either give a thumbs up or a thumbs down to a message, and then this can later on be used for, analysis of response types, as well as overall user experience. So we'll do that now. Okay, so let's open up our Explorer and let's create a new component, and we will call this feedback buttons. Feedback buttons.tsx. And as always, we'll first define the interface for the feedback buttons. First will be the message ID, which will be a string. Then we'll have the current feedback. So we're going to create a type. So this will be message feedback type, which will either be thumbs up or thumbs down. And so that will be message feedback type. And that should also support null if there's no feedback being provided. And then on feedback, so this will be a function. And so this is a callback function when the user clicks the feedback button. And so it'll take obviously the message ID, so the message it's associated with, as well as the feedback, which will be a message feedback type, and it will return void. So now that we have that, let's define the actual components. So export default function feedback buttons. So we've got the message ID, just destructuring them here, the current feedback and the on feedback like so. What's the type? It is the feedback buttons prop. So this is a very simple component that'll just return some UI. So it'll have its container, which is a div, and the class name. So flex items center. We'll justify end because we're going to push it to the right hand side, and space x2, so the space in between the buttons. So I'll have a thumbs up button. So this on click, well, what will happen here? Well, we want to call our on feedback. We want to pass in the message ID, and we also want to pass in thumbs up like so. And then we'll also have some styling on it. So we'll add some padding, give it a border radius, and then as well as that, we need to update the color based on if it's been checked or not. So current feedback, if it's thumbs up. So this will be a ternary. If it is, it'll be text green. So text green 400 and BG green 900, and give it 30% opacity. Otherwise, it'll just be slate. It'll just be normal. So text slate 400, hover text green 400. And then in here, we're just going to add in our thumbs up emoji. And then I'm literally just going to copy and paste it and do the reverse for the thumbs down. So this will be thumbs down. This will be red 400, red 900 over 30, and red, and let's change it to thumbs down, like so. Give that a save. Next, we'll update our message metric props to now include feedback functionality. So message metrics up to the top here. So underneath the message ID, we'll have a current feedback, and I'm now going to export this type, message feedback type. As well as that, we'll then also have our on feedback, which again is the function which has our message ID, which is a string, and our feedback as well. Feedback. And again, that will return void. Then we'll destructure those from our props on message ID and on feedback. So if I scroll down to the bottom, underneath here, we will add a div. So the class name will be flex items center space x1. And then in here, we will have our feedback buttons. We need to add in our message ID, which will just be the message ID. We'll need the current feedback, which will be the current feedback, and we need to destructure that as well. And then finally, we also need to pass in the on feedback as well. On feedback, give that a save. So now we need to go to the message and update our message metrics props. So if I go to you can see we're now getting an error in our message metrics. So at the top, at the interface, I need to now add on feedback. This function needs to be passed in from the top level. So again, we have our message ID and a string. And again, we're repeating this a lot, this type, so you should probably put it into a type and then reuse it like what we're doing for the feedback here. So this will be message feedback type, and that will return void. Destructure that here. So on feedback, and then underneath here, we need our current feedback, which will be message.feedback default to null. And then on feedback, we will pass in on feedback. Give that a save. And then finally, at the page level in our chat, you can see we're getting an error. Whereas that it's in our message because we're not passing in the props. So we'll now create a new function called const handle feedback. This will take a message ID, which is a string, and then the feedback, which will be message feedback type. Import that. And then in here, we're going to call a dispatch. The type will be set feedback, and the payload will be firstly the message ID, and the feedback like so. And then if I go down into my message component, I now need to update the props. And so on feedback, we'll pass in the handle feedback handler. Give that a save. So if we go back over to the app and I say send a positive message, send it. As you can see here, I've now got thumbs up, thumbs down. But when I click on the thumbs up, you can see both are getting marked. And I think that is because I was lazy. And you can see here, the checks are the same. It should be like that. So if I save that, now you can see when I click thumbs up, we get that green background. And when I click thumbs down, we get that red background. Okay, so there we have it. There are all the core requirements covered that was mentioned in the README. If you wanted to turn this into a portfolio project, there are many ways you could extend it. I would recommend just looking at ChatGPT and try to replicate as much of the functionality as possible. So you could make the chat context aware by passing in the entire chat history. You could also add conversations so that you could have different conversations discovering different topics and then allowing a user to pick different conversations. Obviously, you'd have to hook it up then with a database if you wanted to store things persistently. Overall, though, I think it's a great project. You've shown you can work with Python's Fast API, WebSockets, how to interact with LLMs. You've used React, Tailwind, TypeScript, as well as Docker. So overall, I think it's a great take-home project where you can show off a lot of your knowledge. And so if you want the full code, the link to that is in the description. And again, if you're struggling with technical interviews, I was there. I highly recommend you check out techprep.app. It helped me land offers from top tech companies like Amazon and Stripe, and I'm sure I'll do the same for you. If you enjoyed it, please like, subscribe, and share with a friend. It helps the channel out a lot, and I will see you in the next one.